Hi, Pam Nafsinger here. I'm going to take the next few minutes to demonstrate a couple of our precious metals analyzers. I have the handheld XL2 100 as well as the benchtop model DXL. Before we get started with measurements, I want to take a few minutes to point out a couple of the physical features of the analyzer. This is the measurement window. It's 8 millimeter diameter. This is where the sample will come from. So our analysis, what is ever in front of this window, will be what the results of the screen become. The measurement will continue as you have the trigger pulled, and as soon as you release the trigger, then you'll have a final result on the screen. While you're taking your measurement, there will be a real-time update of results on the screen. And again, when you release that trigger, the final result appears here and also is automatically saved in the memory for later recall. So what I'd like to do first is, I do want to also mention that I've got the instrument hooked up to a computer. The instrument works completely independently of the computer, but this way we'll be able to see the measurement results here on a bigger screen just for easier viewing. So I want to get started with a known standard. This is a 14 karat gold standard. It has gold, of course, along with copper and some zinc and some nickel. This is the area that I need to measure. If I'm not straight on this, you can see it's just slightly bigger than my measurement window here. Then we're going to be picking up materials that is not reflective of the material we want to analyze. So I'm going to put it as close as I can right on there and pull the trigger. And I like to give this about, close to a 10-second measurement is time to get plenty of information there. So here we go, 10 seconds. Let me release the reading there. And now let's take a look at what our results are. What we have here on the far left column are the elements that we detected. We've got the gold, we've got the nickel, we've got the zinc, we've got the copper. In the middle column, we have the concentration of each element in weight percentage. And on the right hand column, we have an associated error for each element, and that is in 2 sigma precision. We also will notice that it notes the carat right here, the carat value, and there is a little notification up here that says gold plate not detected. This is the audit feature that we talked about earlier, the gold plating detection system. So let's now check what our standard is. Our standard is a 58.72 concentration for gold, and we have 59.07, so we are off by about 0.3, which is still a very tight measurement when you take and consider our bias right here. So what that does is validate that the instrument is doing exactly what it's supposed to do. So let's move on then to some other samples that some are known and some are unknown. This sample, for instance, here has 2 hallmarks in the side of it. One says 14K and the other one says 58.5. 58.5 being the percent of what gold, being the percent that is equal to 14 karat. So let me take a measurement here. We'll see what we've got. Well, as we can see, it doesn't take a very long measurement to discover that we've got this big flag up here that says gold not present. We look down here and sure enough, there is no AU listed. So what we see is we got lots of copper and some lead and some tin. That's a recipe for a common bronze. So what we found now is that this common bronze ring was trying to be passed off as 14 karat, and it's really easy to discover with XRF that that is not the case. I've got another ring here that is marked 14 karat, and so let's see how it does. Again, we'll put the analyzer window straight over that. And here we've got a result of just about 14 karat. It's a little shy of a true 14 karat at 56.5%. So it's pretty much the real deal. And then this ring right here, I do not have a hallmark, or at least I could not find one on it. So it is a true unknown. So let's take a minute and see if we can find out what it is. And right away you see we've got a message up here that says gold plate probable. And why is it flagging it as this? Well, we can see we've got low gold concentration, which of course equates into a low carat and a non-standard carat at that. And also the real dead giveaway is this really high nickel concentration. Yellow golds should have very little nickel concentration in them. The higher the carat, the less nickel they're going to have. In fact, they should just have trace amounts of nickel. The white gold, of course, will have a several percentage, but this right here is a dead giveaway that it's plated. Okay, so seeing that, let's move on to the DXL here. Now, both of these analyzers have the exact same analytical capability. It's just a matter of preference of a form factor. So I'm going to show you that right here. You'll notice that the window size is the same. It's an 8mm window. And we don't necessarily, there is a really nice little feature here about this one though, is that when I place a sample on here, you can see it in the window, so it's nice for the sample placement right there. And you can also take a picture of it and be able to download it into a report format if you'd like. So I'm going to push the button, initiate our reading, and you can see the real-time analysis there. And I've got it set for a 7-second reading, so it stops automatically. We've got just about a 14 karat, real nice, and rest of the elements that are listed there. Gold plate not detected. I'm going to try. I would like to note that it's not just gold, yellow or white gold that we can measure. We can measure other precious metals as well. So let me show you here. I'm going to put just a tiny bit of this ring, the band of the ring in there. And again, as long as we get it centered well, just a little bit of material is able to still produce enough signal to give us a good reading. And here we see that gold is not present, but that's okay because it's a platinum alloy and gold's not in that platinum alloy. And I will do one more. Again, we can position it using the camera. And again, we have a gold not present, and that is because it is a fine silver. Okay then. So here we have it. We have fast, accurate, non-destructive analysis of precious metals alloys, courtesy of X-ray fluorescence technology. Thanks. We appreciate you being with us today.